Hello, welcome back to the May 2025 IB Chemistry Exam walkthrough. This is the HL subpart of question 1B from paper 2. If you want the subparts that are kind of in common with SL, you can watch the video here and just the whole playlist here. It's a million years long. Anyway, so this is the last part of this question 1. And so this is an organic type of subpart. We're immediately starting off with how we have this cyanide ion that reacts with iodomethane. The one thing you should recognize is that this iodomethane is a halogen-alkane. Very reactive guys. We see them in so many types of reactions. And that this cyanide ion is, we already established in this part with part C, that the cyanide ion was a Lewis base that's going to donate its electrons, which also means that it's a nucleophile. This iodomethane is, you have this C, H, 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 I. And so this I is more electronegative than that C. And so that makes this a partially negative, and that carbon, therefore, partially positive. So that carbon is electrophilic. Okay. Meanwhile, this cyanide ion is a nucleophile because of its negative charge in that lone pair of electrons. Okay. And so that means nucleophiles are attracted to electrophiles. Oh my God, crazy. Boom, arrow, there to form a bond. But carbon can't have 5 bonds, so that I is going to act as a leaving group and leave. And so this part 1, where it's drawing the structural formula of the organic product, this is a substitution reaction. So it's literally just the same guy, H, 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 and then your cyanide. Okay, which we already established way back in like 1A of this question, and that's what CN looks like with the Lewis structure. Okay, so that is going to be the structural formula of the organic product. Okay, it's important to note that that says structural formula, so you need to actually draw the carbons and the hydrogens, and also that that's not really the kind of skeletal structure there. The next part is to predict with a reason whether this reaction will occur by an SN1 or an SN2 mechanism. Okay, and so the big difference between SN1 versus SN2 is that SN1 is going to be unimolecular. That's what that one stands for. And therefore, it is going to be a two-step mechanism, because its rate is always going to be affected by the concentration of the substrate, not the nucleophile. That's why it's unimolecular. It's because the nucleophile comes in a second step. So that had that kind of cation formation, that cation intermediate. Meanwhile, this SN2 is going to be bimolecular. Okay, so that means that its rate is going to depend on both the nucleophile and the substrate. Okay, and that is because it is only one step. Okay, all of these facts are related to each other and should kind of be a chain thought, if that makes sense. Okay, and so whenever you're trying to distinguish which is which, like kind of predict, because this is going to be this is a primary halogenoalkane. Okay, so that's a primary halogenoalkane, and so whenever you're deciding on whether or not it's going to form SN1 or SN2, is you essentially just need to think about its cation stability. Okay, and so whenever you're thinking about its cation stability, dear God, okay, is you need to look at the possible cation that it's going to form. Come back. Focus. Focus. There we go. Okay. Is that if it were to undergo an SN2 mechanism, it would form this. Let's go over here. Is cross this out. Is as if it were an SN2 mechanism, is you would have this iodine leaving first, and so it would form this primary cation. Okay, and so whenever you're thinking about the cation stability, is that so SN1 would form a cation, and so cation stability is the more carbons that you're cation is attached to, the more stable it is. Okay, so cations essentially like you have like primary, secondary, tertiary. And so since that primary is giga unstable, it is not going to undergo an SN1 mechanism. Okay, it's going to undergo an SN2 mechanism. Okay, you don't have to say all of that. They're honestly satisfied with like they do accept that, but also you can literally just say SN2 because primary halogenoalkane. But in terms of what that primary halogenoalkane means, is that literally just means that it would form the primary carbocation. If it were to be SN1, that's unstable. It's not going to do that. Okay. You don't have to say all that though. And so this part 3 is to explain how you might experimentally conclude whether the mechanism in SN1 or SN2. This was one where whenever I took the exam myself under the time conditions, is I sat there and I kind of thought, and I was like, what? And I kind of started and then I came back to it. It's like I started, so like at first I genuinely couldn't figure it out. And I was like, okay. Or my kind of thought process, I was like, oh, like TLC maybe, like if you like did like a like I'm thinking I'm imagining myself doing experiments. I'm kind of like, oh, like if I had like a TLC, like if I did a TLC in the middle of the reaction, like if I saw an intermediate or not, like a third spot that didn't match the reactant or the product, like maybe something like that. And I was like, that feels excessive for this type of question. Like I feel like it's something that is more simple than that. Like that feels too complicated, you know? um is like I feel like explaining all of that seems like more than something the IB would want me to say, you know. And I was like, oh, maybe like HNMR once again, like I'm thinking intermediate, like how can I see if there's an intermediate or not, right? And so then I was like, wait, okay, that's all of that is a bit too complicated. So I'm like, okay, let me come back to it. I finished my exam, I came back to it and I pondered it some more. And I was thinking, I was like, okay, where what is like SN1, SN2, I was like, oh, like maybe it's the because the what's the word is the SN2 has that if it's a chiral carbon, then it's going to be the opposite configuration. So like, oh, is this chiral? Is it a chiral? No, it's not. So it's not that, right? And I was like, okay, what's the other like overlap? Like, how else do we distinguish SN1, SN2? And I was like, oh wait, this part of the curriculum is linked to. We already established this whenever we were brainstorming earlier. Is the rate laws? The rate laws. It's a kinetics question. Okay. And I was so happy that I got this in the end because I was like, so I was just pondering it for such so. So this is what I mean whenever I say that, like, whenever you're done with your exam, is you need to sit there and you need to just ponder. You need to reach deep into your brain, right? Is you need to don't just give up. Okay. Because if you think about something hard enough and you just keep making links, hopefully, eventually you can stumble upon something that might make sense. Okay. You should try and get through the exam with enough time to leave yourself time to do that for questions that are more difficult, like this one. So like I had, I think, 30 minutes left for pondering in my own timing. Anyways, so the answer to this one is like kinetics. And so essentially it's just kinetics experiment. I'm just going to put experiment where essentially if you modify the concentration of, because the difference in SN1 and SN2 is that both of them rely on the concentration of the substrate with the rate law, but only SN2 relies on the nucleophile. So you would modify the concentration of the nucleophile and see its effect on the rate. Okay, and so if it did affect the rate, that would mean that it was this SN2 mechanism. If it did not, if it looked to be zero order with regards to the nucleophile, then it would be an SN1 mechanism. Okay, that would be a way that you could see that. Okay, and so this is also another kind of example of how you may have a thought and you need to think of, does this seem like something the IB would want? Like I said, where I was like, oh, intermediate, NMR, TLC, where that was like a lot of detail. And I was like, that doesn't feel like that feels like beyond the scope. Like that feels like me kind of relying on my own lab experiments as a graduate student. Like that's, too much. And so it's like something that is more obvious, more a link that is more explicit um, in the curriculum. So, and that would be that part D.